In this unit, we're going to be talking about bonding and the structures of molecules. And today we're going to start with covalent bonding. Now, covalent bonding occurs between non-metal elements only. So we're talking about those elements that are right of the staircase. Okay, so if you remember, all of our nonmetals are over here on the right side of the periodic table, our nitrogen and our oxygen, and we're also talking about hydrogen. Okay, hydrogen's in the first column in the alkali metals, but it is a nonmetal. Okay, now the reason why that covalent bonding occurs is because of electronegativity. So our electronegativity values are too similar. So if you remember, our electronegativity is an atom's ability to steal electrons, okay? And it's a scale of 0 to 4, and fluorine, top right, is going to be the largest. Now, when you have two elements that are very, very different, if you have a 1 and a 4, then that 4 is going to steal the electrons really easy. But elements that are beside each other on the periodic table, like say nitrogen and oxygen, well, their electronegativity values are very, very close. And it's kind of like a tug of war with an evenly matched team. Nobody's strong enough to steal the other's electron. So what they're going to do is elements or atoms share electrons. Now, the whole reason they do this is in order to fill the outer shell, in order to fill that valence shell of the atom. Okay, all atoms want 8, so that's what our whole goal is about this. Okay, so we are only concerned with valence. All right, so let's look at carbon and hydrogen. All right, so carbon has 4 valence electrons. Hydrogen has 1 valence electrons. Okay, so hydrogen is one of the ones that breaks the rules. It does not need 8 to be stable. It only needs 2. That's because that first ring can only hold 2 electrons. All right, so these two atoms are going to share those 2 electrons. Well, now hydrogen actually has the ability to use both of those electrons, and it's stable, and it's in a no longer needs more electrons because it's sharing. But this carbon has 3 electrons that are not paired. It doesn't have anything to share, so it's unfilled. So what we need actually is more hydrogen atoms to come along and share with the carbon. So now as you look, each one of these hydrogens has 2 electrons that it can use, and the carbon now has 8 that it can use. So when you have a section like this of the 2, both of those electrons are being used by each atom at the same time. Okay, and this is what covalent bonding is. The formula for this molecule will be CH4, okay, also known as methane or carbon tetrahydride, whatever you feel like. Okay, so a shortened way to write this would be with dashes. And each time you see a dash written like this, the dash means a shared pair. Okay, so there's a couple of ways that you can draw these, but either with the dots or with the dashes. All right, let's look at another example. Let's look at carbon plus chlorine. Carbon again has 4 electrons in its valence shell. Chlorine has 7. Well, they're going to share these two here. Now chlorine has a full 8 and it's happy. But we have the same scenario. Carbon has 3 empty spots that need to be filled. So what we're going to end up with is more chlorine coming around the carbon and filling in these gaps. So we're going to share each one of these little pairs. Okay. Now the reason I talk about those dashes, all right, you can redraw this as carbon. The dashes only represent shared pairs. You're not going to put these little dashes out here representing all these other electrons. You only have to draw the shared pairs. Okay, so that's kind of the shortcut or the abbreviation. All right. Now, something else we need to talk about is something called diatomic. Now, the diatomic atoms or diatomic elements, these cannot exist alone in nature. Okay, there are 7 of them. Now, what I mean is, if you find any of these elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine, if you find any of these atoms, you will actually never find a single solitary atom in nature. They will always be paired with something. They must be paired with something. They are incapable of existing alone. And if they pair with themselves, that's okay. So we can have H2, N2, O2, F2, Cl2, Br2, I2. But you're never going to see just a single atom, okay? So I call these affectionately the Big 7, okay? The Big 7 because there's 7 of them, but if you look at the periodic table, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, it actually makes a shape of a 7 on the periodic table. And then you just have to know hydrogen over here. Now this becomes way more important when we're doing formulas and especially reactions. But you have to know these. You have to memorize these 7 elements, okay? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And say them over and over again, hopefully they'll stick. But this is just something that you have to memorize, all right? But let's look at the covalent sharing of some of these. So let's first look at chlorine. So if you remember, chlorine, like we just said, has 7 valence electrons. And Cl2 means that there are 2 chlorines. Okay, so what they're going to do is they're going to share their single 7th electron that is off to the side there. Okay, and we end up with a Cl-Cl. Okay, that dash means a shared pair. It's also called a single bond. Okay, a single bond when 2 atoms share 1 pair of electrons. Pretty plain and simple. All right, let's look at oxygen. Oxygen has 6 valence electrons. Okay, so if I O2, it's diatomic, so I got to have 2 of them. So we're going to share right there, but then I have these 2 spaces that are left over on the two atoms. So what actually needs to happen is they're going to share here as well, and I end up with a molecule that has two lines, and this is called a double bond. So a double bond is when two atoms share two pairs of electrons. Okay, pretty straightforward. What do you think's next? Nitrogen has 5 valence electrons. It's diatomic, so you have to have 2 nitrogens. Okay, so we're going to share here, we're going to share here, and we're going to share here. And we end up with a structure that looks like this. This is called a triple bond. Okay, so a triple bond, when two atoms share 3 pairs of electrons. Okay, so remember, these dashes are for showing the shared pairs. You don't have to write your dashes over here on the side. Okay, you only, when you're writing that abbreviated form, you're just talking about the shared pairs. Okay, and I always have students ask me, what about 4? What about a quadruple bond? Well, when we talk about structure and something we call VSEPR, then we can talk a little bit more about that. But a quadruple bond is not actually going to happen because of the nature of electrons and where they hang out on the outside of the atom itself. So otherwise, that's actually about it. Okay, you need to know your, it's non-metal, non-metal. You need to make sure that you know your valence electrons. Okay, and know whether or not you're going to need to add another atom. Okay, don't take anything away, just add atoms as you need them. Okay, next class we're going to talk about ionic bonding, but until then, work together, help each other, and make the world a better place. See ya.